Welcome back. This is Matt with Camping and Coding. We are continuing our work through of the LeetCode 75 study plan. As a reminder, I'm doing this to sharpen up my own skills and hopefully help you along the way. Okay, so our problem here is the greatest common divisor of strings. So we want to know for two strings whether string 1 or what the greatest common divisor of string 1 and string 2 is. So greatest common divisor is defined as for two strings s and t. We say that t divides s if and only if s is a concatenation of t with itself one or more times. Okay, so before we get into this problem itself, let's take a look at the examples just to help us understand. So here, ABC is a divisor of string 1 and a divisor of string 2. That's good. AB is a divisor of both strings. That's good. Here, there is no greatest common divisor, so we output an empty string, and so too with example 4. Now we are looking for the greatest common divisor, right? So that's interesting because in example 2, you might think, well, ABAB, that substring appears in string 1, but it doesn't divide string 1 because it's too long. Okay, in our constraints, we know that neither string is going to be empty, and they consist of English uppercase letters. Okay, before we get to coding, let's think about the algorithm we're going to use here. So first, we're going to set the divisor to whatever the shorter of the two input strings is, because necessarily the divisor will be less than or equal to the length of the shortest string when we start. Okay. Then while the length of the divisor is greater than 0, so while we haven't used up all the characters in the divisor, first check if the divisor's length evenly divides both strings, and if repeating it reconstructs both strings exactly. So that second part there, the second condition, is just this concatenation piece. The first condition is a shortcut that helps us save some runtime. It doesn't do anything for us asymptotically, but it does save some cases where maybe where we don't want to concatenate long strings to each other, right? That takes time. It's linear with respect to the side of the input. We don't want to do that, so we can just check with math, and if the lengths are not such that it could possibly be a greatest common divisor of one or both of the strings, then there's no reason to continue. Okay, so if it satisfies both of those conditions, then return that divisor. Otherwise, remove the last character from the divisor, shrinking it by 1. If we get to the end and we haven't found a divisor, just return the empty string. So let's code this out. So our divisor is equal to string 1 if the length of string 1 is less than the length of string 2. Otherwise, it is string 2. So the divisor is the shorter of the two. Now, I want you to think about why we might use a separate variable here for the divisor instead of just directly using the shorter string. Think about that and see if you can come up with the logic behind that. Okay, so now let's go to step 2 of our algorithm. So while the length of the divisor is greater than 0, first we want to check numerically, could this divisor possibly be, does it go into both of the strings evenly? So we'll say if the length of string 1 mod the length of the divisor is not equal to 0, so the divisor does not go in, the length of the divisor does not go into the length of the string evenly, or the length of string 2 mod the length of the divisor is not equal to 0. Then we just shrink it by 1, removing the last character. I talked about in the last video this string parsing in Python. We did the opposite there. Here we're just, if the left side of the colon is empty, that just means keep everything up to but not including this index in my new string. Now our second condition. If repeating it constructs both strings exactly. So Python is very useful here. You can do this sort of in other languages. I mean, you can certainly solve this problem in other languages. It's just not quite as clean and easy as it is in Python. If you would like to see that in a different language, let me know. I can do that, C++ or Java or whatever. Okay, so we want to know, is S a concatenation of T one or more times? So to do that, we're going to say if the divisor, the string itself, so that's the divisor string, times the length of string 1 divided by the length of the divisor. If that equals string 1, then we know that that string 1 is a concatenation of the divisor one or more times. And if the divisor times the length of string 2 divided by the length of the divisor equals string 2, then string 2 is a concatenation of the divisor one or more times, and we return the divisor. This is a neat Pythonic way to compare strings of different lengths with each other like this, or construct strings. So pretty simply, if you were to think about the string AB, if you multiply it by 3, that would be AB, AB, AB. So it's a handy trick in Python. Again, you can do something equivalent to this computationally in other languages. It's just a lot easier in Python. Otherwise, so this is the case where one or both of these is true, that the divisor's length does not one or both of these is false. The divisor's length does not evenly divide both strings lengths, or repeating it does not reconstruct one of the strings, then we just want to shrink it again. And I shouldn't say we want to shrink it again, because we're not shrinking it twice. These are separate if-else branches only, and exactly one of these will execute. So we will at most shrink this by 1, shrink the divisor by 1. Okay, and if we get to the end of the while loop and the divisor is equal to 0, if the length of the divisor is equal to 0, then we just return an empty string. We can also just return divisor here. It doesn't really matter. Okay, and you can restructure this in a bunch of ways. There are many ways to rewrite this. For example, you could maybe combine these branches in a clever way, since they're doing the same thing. Yeah, so there's a bunch of ways to do this, but I think this is the most clear for instruction purposes. So let's run it and see if it works. It does. How exciting. All right, let's submit it and see if it passes other test cases. It does, slowly. So this is interesting. I mentioned this in the last video as well. Take these LeetCode runtimes and memory usage numbers with a grain of salt. LeetCode is not precise when it comes to these things. They're very susceptible to very small fluctuations that are totally outside of your control. What matters is asymptotic runtime. So let's try it again, just for grins, and see what happens. Yeah, okay, same thing, and you'll notice our memory is much better this time, which doesn't make any sense because nothing has changed, which means something that is outside of our control is affecting these results. So let's think about the asymptotic runtime and space usage. So let's start with space. Asymptotically, this is big O of n, because we are just making divisor equal to the shortest of the two strings. We don't know how long the shortest string is, and even if the shortest string were 1 character long and the longest string was 1 billion characters long, this would still be O of n, because we're talking about asymptotic runtime here. We aren't looking at a specific example like that. The point here is that the space usage does not grow, it grows linearly with the input characters. It does not grow super linearly or exponentially or something like that. Okay. And what about runtime? So we are iterating over the divisor. We're also doing this little trick here where it looks like we could be iterating over all of the characters of both of the input strings inside a loop, which would give us O of n squared runtime, and that would be very bad. We don't want O of n squared for a problem like this. But because of the neat little trick that Python gives you where you can multiply a string by an integer and create a version of that string concatenated with itself that many times, this just happens to be constant time. So that's very good because that means our asymptotic runtime is still linear. It's big O of n. Now, I'm just curious, or I don't know, hate myself in some way. So I'm going to see if I can get a different number than 21.03, and I cannot. So that is remarkably consistent for a system that I just said was inconsistent. You can trust me or not. Go try it for yourself. What matters here and what will matter for interviews is the asymptotic runtime. Okay, I hope that was helpful, and I'll see you next time. Thanks, bye.